Isolated ground receptacles provide a dedicated ground path separate from the building's electrical system. This prevents electrical noise and interference from entering equipment connected to the outlet. The exo-terminal of a transformer is the neutral point of the transformer's secondary winding. It's connected to the building's grounding system to provide a path for fault currents and to stabilize the transformer's neutral voltage. To properly connect isolated ground receptacles and the transformer's exo-terminal, firstly, install isolated ground receptacles in the required locations. Each receptacle should have a green insulated ground screw and a receptacle faceplate with a no equipment ground label. Secondly, run a green insulated American wire gauge wire from the isolated ground bar in the electrical panel to the exo-terminal of the transformer. This wire will serve as the isolated ground conductor. Thirdly, connect the green American wire gauge wire to the isolated ground bar in the electrical panel. This provides a dedicated ground path for the isolated ground receptacles. Fourthly, connect the other end of the green American wire gauge wire to the exo-terminal of the transformer. This establishes a direct ground connection between the isolated ground bar and the transformer's neutral point. The isolated ground conductor should be sized appropriately for the load that will be connected to the isolated ground receptacles. The isolated ground system should be tested and verified to ensure proper functionality. It is important to follow all applicable electrical codes and safety regulations when performing this installation. The purpose of an isolated ground is to reduce electrical noise. Normal grounding systems can sometimes carry noise which can interfere with sensitive electronic equipment. By providing a separate, isolated path to ground, the noise is minimized. This is especially important for audio equipment, medical devices, and computer systems. The green insulated wire is essential for safety and code compliance. It clearly identifies the isolated ground conductor and prevents accidental connections to other grounding systems. The no equipment ground label on the receptacle faceplate is another visual indicator that the receptacle is part of an isolated ground system and should not be connected to our standard equipment ground. When selecting the appropriate American wire gauge size for the isolated ground conductor, consider the maximum current that the connected equipment might draw. Consult electrical codes and tables to determine the correct wire size for the expected load and the length of the conductor. A proper test of the isolated ground system should verify that the resistance between the isolated ground conductor and the building's main grounding system is very high, indicating good isolation. It should also verify that the isolated ground conductor is properly connected to the transformer's exo-terminal and the isolated ground bar in the electrical panel. Here's a more detailed explanation of each step. Firstly, carefully select the locations for the isolated ground receptacles. Consider the equipment that will be plugged into these receptacles and the potential for electrical noise in the area. Install the receptacles according to the manufacturer's instructions and local electrical codes. Ensure the green insulated ground screw is securely tightened. Secondly, choose the correct American wire gauge wire size. This will depend on the amperage of the circuit and the length of the wire run. Use an appropriate wire stripping tool to remove the insulation from the ends of the wire without damaging the conductor. Thirdly, the isolated ground bar is typically located within the electrical panel. It is a separate grounding bar that is specifically designated for isolated ground circuits. Connect the green American wire gauge wire to the isolated ground bar using a proper grounding connector. Ensure the connection is tight and secure. Fourthly, locate the exo-terminal on the transformer. This terminal is typically identified with a label or marking. Connect the other end of the green American wire gauge wire to the exo-terminal using a suitable connector. They then ensure the connection is tight and secure. The isolated ground conductor provides a low impedance path for fault currents to flow back to the source. This helps to quickly trip a circuit breaker or fuse in the event of a ground fault, protecting people and equipment from electrical shock and damage. The transformer's exo-terminal is the neutral point of the transformer's secondary winding. Connecting the isolated ground system to this point helps to stabilize the neutral voltage and prevent voltage imbalances. Here are some additional considerations when installing isolated ground systems. Firstly, always to energize the circuit before working on any electrical connections. Secondly, use proper personal protective equipment, such as safety glasses and gloves. Thirdly, carefully inspect all connections to ensure they are tight and secure. Fourthly, label all components of the isolated ground system clearly. Fifthly, document the installation for future reference. Sixthly, follow all applicable electrical codes and safety regulations. Seventhly, if you are not comfortable with any part of the process, consult with a qualified electrician. Isolated ground receptacles and systems are specialized components that require careful installation. By following the proper procedures and taking the necessary precautions, you can ensure a safe and effective installation that provides reliable protection against electrical noise and interference. Always refer to the latest edition of the National Electrical Code, also known as NEC, for specific requirements and guidelines related to isolated ground systems. The NEC provides detailed information on wire sizing, grounding methods, and other important aspects of electrical installations. It's essential to have a thorough understanding of the NEC requirements before undertaking any electrical work. In addition to the NEC, local electrical codes may also have specific requirements for isolated ground systems. Be sure to check with your local building department to determine if there are any additional regulations that apply to your installation. A proper isolated ground system installation requires a combination of knowledge, skill, and attention to detail. It's not a project to be taken lightly, and it's always best to err on the side of caution. If you have any doubts about your ability to complete the installation safely and correctly, consult with a qualified electrician. Remember, electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others from harm. If you're dealing with a 480/277 volt system, extra care is needed due to the higher voltage levels. 480/277 volt systems are commonly used in commercial and industrial buildings to supply power to lighting, motors, and other equipment. The higher voltage allows for smaller conductor sizes and reduced voltage drop over long distances. When working with 480/277 volt systems, it's essential to use appropriate safety equipment and follow strict safety procedures. This includes wearing insulated gloves and clothing, using insulated tools, and verifying that the circuit is de-energized before working on it. Always consult with a qualified electrician before working on any electrical system, especially if you are not familiar with the specific voltage and wiring configurations. Proper grounding is crucial for the safe and reliable operation of any electrical system. Grounding provides a low impedance path for fault currents to flow back to the source, which helps to quickly trip a circuit breaker or fuse in the event of a ground fault. This protects people and equipment from electrical shock and damage. In addition to providing a path for fault currents, grounding also helps to stabilize the voltage of the electrical system and reduce electrical noise. A properly grounded system will have a stable voltage reference point, which helps to prevent voltage fluctuations and imbalances. Electrical noise can interfere with the operation of sensitive electronic equipment, so it's important to minimize noise levels in the electrical system. Here are some common sources of electrical noise. Firstly, electromagnetic interference from nearby equipment. Secondly, radio frequency interference from wireless devices. Thirdly, ground loops caused by multiple ground connections. Fourthly, harmonics generated by nonlinear loads. Fifthly, voltage transients caused by switching events. Isolated ground systems are an effective way to reduce electrical noise in sensitive circuits. By providing a dedicated ground path that is separate from the building's main grounding system, isolated grounds minimize the amount of noise that is coupled into the circuit. When installing isolated ground receptacles, it's important to use the correct type of receptacle and wiring. Isolated ground receptacles have a green triangle marking on the face of the receptacle, which indicates that they are part of an isolated ground system. The wiring for isolated ground receptacles must also be kept separate from the building's main grounding system. The green insulated wire that connects the isolated ground receptacle to the isolated ground bar in the electrical panel must not be connected to any other grounding points. This helps to ensure that the isolated ground system remains isolated from the building's main grounding system. The exo-terminal of the transformer is the neutral point of the transformer's secondary winding. This terminal is typically grounded to provide a reference point for the voltage of the electrical system. When connecting an isolated ground system to the exo-terminal of the transformer, it's important to follow the manufacturer's instructions and local electrical codes. The connection must be made in a way that does not compromise the isolation of the isolated ground system. In some cases, it may be necessary to use a separate grounding electrode for the isolated ground system. A grounding electrode is a metal rod or plate that is buried in the ground and connected to the grounding system. This provides a direct connection to the earth, which helps to stabilize the voltage of the electrical system and provide a low impedance path for fault currents. The size and type of grounding electrode must be selected according to the requirements of the NEC and local electrical codes. The grounding electrode must also be installed in a location that is free from obstructions and accessible for inspection and maintenance. Regular inspection and maintenance of the isolated ground system are essential to ensure that it continues to function properly. The connections should be checked periodically to ensure that they are tight and secure. The grounding electrode should also be inspected to ensure that it is in good condition and properly connected to the grounding system. If any problems are found, they should be corrected immediately to prevent electrical shock or damage. When working with electrical systems, it's important to be aware of the potential hazards and take the necessary precautions to protect yourself and others from harm. Always de-energize the circuit before working on any electrical connections. Use proper personal protective equipment, such as safety glasses and gloves. Carefully inspect all connections to ensure they are tight and secure. Label all components of the electrical system clearly. Follow all applicable electrical codes and safety regulations. If you are not comfortable with any part of the process, consult with a qualified electrician. Proper grounding and noise reduction techniques are essential for the safe and reliable operation of electrical systems. By understanding the principles of grounding and noise reduction, and by following the proper installation and maintenance procedures, you can ensure that your electrical system provides a safe and reliable source of power for your equipment and appliances.